Hey guys, welcome back to math. Today we're going to do some math that's very similar to the game that we played the other day. So grab your journal. You're also going to need your workbook today, so make sure to have that handy and let's get started. So here's where we're going to start first. So 6 times 1/4. So this is saying 6 groups of 1/4. So what I was trying to show you when we were playing target one fraction is there's more than one way to solve this. So you could think of it as 1, 2, 3, 4, 5, 6. 6 groups of 1/4 using repeated addition. Although now I see it's kind of hard for you to see the plus signs in between because they go right on the line. That's better. So then so when we're adding fractions, remember from our earlier unit, when we're adding and subtracting fractions, the denominators need to be the same and we do nothing with them. So these are all fourths. So I'd pull my fourth over and then I would just add the tops. 1, 2, 3, 4, 5, 6. So 6/4. The same thing can be done with your multiplication, right? 6 groups of 1, which is 6. Out of the 4 you need to make a whole. So just talking about which one is more efficient for you, but the math is going to end up with the same answer. But this is called an improper fraction because the top number is bigger than the bottom. I am going to model for you how to change that to a mixed number every time it pops up, but know that both the improper fraction and the mixed number are both going to be correct answers. So when you have a number on top that's bigger than the one on the bottom, you're going to ask yourself, how many groups of 4 can I take out of this 6? And I can only take out 1. So if I take 4 away from 6, so how many pieces are left? There are 2 left out of the 4 I need to make a whole, which is also 1 1/2. So for this particular answer, you have 3 choices. All 3 of those would be correct answers. You might be thinking about another way to solve this. You can think about money, but money doesn't work for all fractions. It just conveniently works for this one because 1/4 is the same as a quarter. So 6 quarters would be $1.50. Keep in mind that doesn't work for all fractions, but it works really nicely for the fourth. So what would happen if we did 6 times 3/4? 6 groups of 3/4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My brain started getting confused, writing one number, saying another. There we go. So again, same problem, modeled differently, using a different strategy to solve. So repeated addition, again, they're all 4s on the bottom, which is what we want. So we just bring the 4 over, and then we're going to add 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3 to come up with our answer. Or 6 times 3 out of the 4 we need to make a whole. So this would be 18. 6 times 3 is 18. So 6 times 3 is 18. Out of the 4 we need to make a whole. Or 3 plus 3 plus 3 plus 3 plus 3 plus 3 is 18. Same thing. But just like I did before, we've got an improper fraction. We have 18 out of 4. 18 out of 4. So we want to fix that and make it a mixed number, right? Mixed meaning a whole number and a fraction. So how many groups of 4 can I take out of 18? So I'm going to model some thinking for you here. My easy facts, 2, 5, and 10. I know that 4 times 5 is 20. Guess what? I can't pull 5 groups out of 18, so that means I can only pull out 4 groups. So then I got to figure out, okay, so 4 times 4 is 16. I have 18, which means there's 2 left behind. Same as 4 and 1/2. Now I want you to do one more problem for me here. You're going to do this one. I want you to solve 6 times 4. Pause there and solve that one. So 4s are double doubles. 6 doubled is 12. 12 doubled is 24. I want to pull the answers down to these other ones. 6 times 1/4 is 1 2/4. 6 times 3/4 is 4 2/4. Take a moment, pause here. I want you to compare these problems. What are you noticing when we multiply this 6? What's happening to the answers here? Pause there. So what I'm hoping that you noticed, when I do a whole number times a whole number, my answer is bigger than either of the numbers I started with. When I multiply a whole number times a fraction, I get a smaller number than what smaller than the 6. I end up getting a smaller number, and then 6 times 3/4. So my answer is a little bit bigger because I'm not working with a unit fraction, but also my answer is smaller than that original 6. Because we're not talking about 6 groups of a whole number, we're talking about 6 groups of a piece. So if I had 6 bars, 2, 3, 4, 5, 6. Six groups. There's halves. Here's fourths, right? So let's say that these are all candy bars and we only have these parts left behind. This is why your fraction is looking smaller, because these parts have already been eaten. This is all you have left. Same thing here, but it would be 3 of those pieces. That is why you're getting a smaller number here. So let's jump over to your workbook. So grab that. You're going to open to page 168. It's called Fraction of a Whole. Page 168. And let's jump in here. So Nathan participated in a 5K race. He walked 1/4 of the way, jogged 3/5 of the way, and ran 3/20 of the way. How many kilometers did Nathan walk? So we're trying to figure out here, what is 1/4 of 5? Same thing as 1/4 group of 5. Remember, in multiplication, we can switch these things around and it's going to end up being the same math. So it is 1/4 of 5. So more than one way you can solve it, right? You can do 1 times 5 is 5. Out of the 4, you need to make a whole. Maybe you're thinking with fourths, right? Half of a half. Or you did repeated addition. So 5/4 is the same as 1 1/4. Keep in mind it's a story problem. We need to put that kilometers back in. So he walked 1 1/4 kilometers. How many meters did he walk? So I'll put a little side note over here. 1 kilometer is equal to 1,000 meters. So why don't you pause here and try and solve this one. Use what we know from here and my little side note. See if you can solve that one. Okay, so 1 1/4. So we know at least 1 kilometer. So we know they're going to be at least 1,000. 1 kilometer equals 1,000 meters. So we know we have at least 1,000. We need to figure out what this 1/4 is going to be. So I'm thinking 1 is 1,000. What's half? Half of that would be 500. If we halved that again, we'd land us in the fourth. So what's half of 500, 250. So 250. So then we would add these two together and come up with 1,250 meters. Okay, how many kilometers did Nathan jog? See if you can come up with the equation to match this problem. Just the equation. So up here, he jogged 3/5 of the way. So jogging 3/5 of 5 kilometers. Now, I want you to pause and solve it. So like I said before, more than one way to solve it. If you did repeated addition, fantastic. If you just multiplied, super. If you had another way, we'll see if you ended up coming up with the same math we did. So I'm going to just use my most efficient tool and multiply. So 3 times 5 is 15 out of 5. So how many groups of 5 can I take out of 15? That is 3. So he jogged 3 kilometers. So how many meters did Nathan jog? Try that one. This one's a little bit easier because there's no fraction we have to figure out. So 3 kilometers, 1 kilometer equals 1,000, so 3,000 meters. All right, next one. How far in kilometers did Nathan run? Pause, come up with an equation. So he ran 3/20 of the 5 kilometers. Pause and solve it. So 3 times 5 is 15 out of 20. So he did not run a full kilometer. He ran less than 1. So how far in meters did Nathan run? So we've got some different denominators here. Before we jump into this meters one, I want you to take a look at these other answers. So we know altogether it's a 5K, a 5 kilometer race. So right here we've got 1 1/4, 3, and 15/20. We know that all three of these together have to equal 5. So why do we have different denominators here? Let's see what happens if we turn the 1/4 into 20ths. So 1/4, we want it to turn into 20ths. So 4 times what gets me 20? Oh, times 5. If I do it to the bottom, I need to do it to the top. So the same as 5/20, which means this is the same as 3/4. Which would make finding our meters a lot easier because we've already done all this work up here. We know that 1/4 is 250. We know that 1/2 is 500, right? The same as 2/4. So then if we add those together, we get 0 and 0, 5, 6, 750 meters. All right, let's try number 2. Deidre's bedroom is 9 square meters. She just got a new rug that covers 3/5 of her bedroom floor. How big is Deidre's new rug? Pause, come up with an equation. So we're trying to figure out what is 3/5 of 9. What is 3/5 of 9? 3/5 group of 9 even. All right, pause again and solve it. So 3 times 9, 27 out of the 5. So now we got to figure out how many groups of 5 can we take out of 27. So I know that 5 times 5 is 25. So it gives me 5 whole groups. 25, 26, 27 needs 2 pieces left over. So 5 times 5 is 25. So my 5 whole groups goes there. I have 25 pieces sitting in these, which means there's 2 left over in that pile. Out of the 5, I need to make a whole. So 5 2/5 meters squared, pulling it from the beginning of the problem up here. All right, turn the page. Write a story problem for 2/3 times 4, then solve your own problem. All right, well, I recorded all of number 3 without pushing the record button. So now I'm going to demo it here, and then you'll see it written on my book. Whoops. So to write your story problem, I want you to come up with any person's name to start with. Give me a someone. Okay, then they're going to have 4 whole somethings. They have 4 cars, they have 4 pizzas, they have 4 ice creams, they have 4 candles, they have 4 rugs. Give me 4 something. Then, what is your person going to do with that 4 something? Are they going to eat it? Are they going to paint it? Are they going to trade it? Are they going to give me a verb? Give me an action that they're going to do with your 4 something. Okay. Now that action is 2/3. So they ate 2/3, they colored 2/3, they gave away 2/3, they did something with those 2/3. To end your story problem, you need to have some kind of a question, right? That's where the whole math part comes in. So you need to have a question that's going to get them to figure out what that 2/3 is. So for example, how much did they eat? How much did they give away? How much did they paint? How much did they, whatever verb you have. And then I'll show you my example. Okay, so Sarah had 4, here's my person, right? Sarah had 4 pizzas. There's my 4 whole somethings. Her and her friends ate. There's my verb. 2/3 of it. There's my 2/3. How much did they eat? And then coming back to the question. So if I would have asked how much was left, that would be a very different problem. That would be 1/3 of 4. We want 2/3. So whatever your question is needs to connect back to the verb you used in the problem. And then we need to solve it. So 2/3 of 4. Pause and solve. Look at that math. I'm so fast. So 2 times 4 is 8. Out of the 3, we need to make a whole. So then when I start thinking about it, 3, how close can I get to 8 using 3? So I know 3 times 3 is 9. That's too big. So 3 times 2 is 6. Good thing I didn't record that because I was writing the wrong answer. 3 times 2 is 6 with 2 pieces left over. Out of the 3, I need to make a whole. So they ate 2 2/3 pizzas. Again, yours is going to say 2 2/3, whatever the verb is from your problem, or your 4 whole somethings. Mine was pizzas. All right, couple more here. Let's move on to number 4. Solve the combinations, show your work. This says using your strategies with your classmates, but guess what? I'm your only classmate right now. So we have lots of strategies that you've used before. So we're going to solve it. I'm going to pause. No, I'm going to pause. You're going to pause and solve those 3 and then come back and we'll check the answers. All right, if your paper looks like mine, you didn't listen, you didn't pause. You should have all 3 of these solved, and now you're just going to check it with me. So if you use repeated addition, fantastic. If you use multiplication, super. If you used a different strategy that I haven't shown, that's cool too, as long as you're ending up with the right answers. I'm going to model multiplication because it's the most efficient strategy for my brain. So 3 times 3 is 9 out of 4. Again, remember this is technically a correct answer, so if this is where you stopped, give yourself a little star. I'm going to keep going. So 4 times 2 is 8, so I can make 2 whole groups with 1/4 left over. And my work would be 3 times 3 equals 9. Okay, so here's this one. We have 6 times 2 is 12 out of 5. So I can make 2 groups of 5 with 2 left over. This one, 8 times 2 is 16 out of 3. So how many groups of 3 can I pull out? 3 times 5 is 15, which leaves 1/3 behind. Ooh, this one, a bit more tricky. How are we gonna solve it? Okay, so for these ones, I'm just gonna walk you through my thinking and you guys can just follow along here. So we have to figure out 1/4 times what equals 9. So if I do 4 times 9, I get 36. So whatever I put here has to end me up with 36/4 so that I can get this whole 9. So my goal is to end up at 36/4 because that's what equals 9. So now I can go over here and say, okay, 1 times what gets me 36? That one is 36. So again, I'm trying to get to 36/4. So 2 times what gets me 36. And what I did for this was I halved it. So I halved 36 because that would be the same thing. So we'll do it here. Half of 6 is 3. Half of 30 is 15. So 15 plus 3 gets me 18. Okay, still going. I'm still trying to get 36/4, just like over here, because that's what the 9 equals. So 3 times what gets me 36. It was easier for my brain to split it out into 3 pieces like this. So this would, if I took 6 and split it out 3 times, 2, 4, 6. And then take the 30, 10 for you, 10 for you, 10 for you. So the answer is 12. And then here, still trying to get 36. 4 times what gets me 36? Well, I did that way back here in the very beginning to figure out what number I needed. So the answer is 9. So what we were supposed to be putting down here is at least one pattern from up here. So just take a look, and what do you notice about the fraction, the number we put in, compared to the answer? So I notice that all the answers are the same, and the bigger the fraction that got, the smaller the amount of them we needed. So I only needed 9 groups of 4/4 versus 12 groups of 3/4, 18 groups of 2/4, and 36 groups of 1/4. So that numerator, that top number, the bigger it is, the fewer of those groups I needed. If you found another pattern, fantastic. Okay, number 6. I'm gonna do the same thing. I'm gonna show you my thinking. If you want to pause here and try it on your own, now that you've seen how to solve the top one, fantastic, but keep in mind, these back answers are changing. It is the fraction that is staying the same. So you might need to think about what I did here to solve these back ones. But we're going to solve it together, never fear. All right, I'm having a lot of technology issues today, so I apologize for this choppy video. But once again, I thought I was recording, and my phone disagreed. So these are the same problems you have on your paper, but I have to do them in my journal because they're already done. So here we go. We have 1/5 times something needs to get us to 15. So I need to figure out how many fifths is equal to 15. So 5 times 15 is what we're trying to solve, so we can figure out how many fifths that is. I'm going to zoom in a lot closer so you can see what I'm doing. So 5 times 15, I'm going to solve this. So 5 times 5 is 25. 5 times 1 is 5 plus 2 more, 6, 7. So my answer, 15 is the same as 75 fifths. Right, so if you think back to the other problem, we were trying to make them into whole numbers, right? So we need to end up with 75 fifths to get to 15. So 1 times what gets me 75? The answer is 75. So next one here, we need to figure out how many fifths is equal to 30. We do that by solving 5 times 30. If I look at the math above, right, this is a double. This first number is staying the same, which means my answer is going to double. So 75 doubled is 150. So 150 fifths is the same as 30. So 1 times what gets me to 150? Sorry, I just had a little panic attack. I thought I wasn't recording again, but we're good. So moving on, how many fifths is equal to 60? So 5 times 60 equals what? I noticed from above, we've got another double here. So this is also going to double. So 150 doubled is 300. So 300 fifths. 1 times what gets us to 300? 300. Last one here, same thing. How many fifths is equal to 120? So we're doing 5 times 120. Another double, which means another double. 1 times what gets to 600? 600. So here's all that back in this book. Let's take a look at some patterns that we see through these 4 problems. Stop and take a look at that. So I noticed the fraction this time is staying constant. Above, the answer was the thing that was staying the constant here, but here it's the fraction. So 1/5 of 75, as this group, this number of the 1/5, the groups of them, gets higher, the answer also gets higher. But I also notice that the answer is much lower than the number I'm putting in the problem. So the answer ends up being smaller, but the bigger this group number gets, the bigger our answer gets. Good work today. There's some challenge problems at the bottom if you want to give those a shot, like the ones we've been working on above. But the next page over is your independent work today. Remember, this page is really important. The lesson we do together, I give you all the answers. So naturally you get 100%. That doesn't tell your teacher what you know. This is where your grading is coming from. This is an effort. This is a what do you understand. These independent pages are very important. So this is your page for today. Show your work on the page, or if you do it in your journal, take a picture of both. And I will see you tomorrow with another lesson. Bye, guys.